Okay, thank you very much. I'm going to talk about the exploration of large omnidirectional datasets. Omnidirectional and 360 panoramic images are really commonplace now. I don't have to preach to this session and can be used by anyone, but these are typically in the order of 25 megapixels or things like that. We are looking at a data set that are an order of magnitude larger than that. And specifically, we have been working with GIS data, and we want to explore these GIS data in an omnidirectional, immersive fashion. So we look at the GIS, for example, of the Earth from the inside out. That's how we project it on the surface of the Earth from the inside. And we combine several techniques to support this kind of an application, specifically using teleportation and kinematic navigation. Part of it is allow us to automatically scale the data in a hierarchical way. If you're in the middle of the Earth, you get one scale. You get close to the surface, automatically you get a different scale. We also, in order to do teleportation, we use magnification for pick and wrap, and we have a transition for the teleportation that we call Envelop that I will introduce, and we compare it with 3 other teleportation transitions. So basically in Immersive GIS, we have a variety of layers of data, elevation data, wind velocity, population. In this application, we added some demographic data that I'll show you later. But due to the large size, we really need a technique to be able to explore and analyze this data. And as I mentioned at the beginning, we look at the Earth from the inside out in an immersive way on a head-mounted display. The automatic scaling is allow us to scale the virtual model dynamically. If you are at the center of the Earth, the sphere is scaled down so it can fit in the physical room, and we allow the user to walk in the inside room, which the physical room, which is typically a small room. And when teleportation gets us closer to the surface, the model is automatically scaled up. So, and again, the surface fits on the room edges, and we are inside the room. We have to constrain the scaling in such a way that to remove offsets between the target sphere and the original sphere. And for example, in this animation, I show the yellow figure inside this square room. Maybe it's a little bit difficult to see, but in the middle there's a square room. And this is bounded by its own sphere. On the left-hand side, we have the current sphere. We want to get to the right-hand side, and we have to use this arc transition so we can transition from one engulfing sphere to the destination one. Before we do teleportation, we have a zoom lens that allow us to pick before the teleportation. You can see this. This is a head-mount display. We have a stereo for both eyes, and we do zoom in and then teleport to the selected location. So we developed a technique what we call Envelop. Basically, we increase the size of the magnification lens. We have a magnification lens that allows us to explore the target location. And we enlarge this magnification glass to a point that it's completely enveloping or engulfing the user. That's why we call it an envelope. And this alleviates some issues that are with other teleportation transitions. We don't lose the spatial context, and we reduce the simulation thickness. So here we have a video that compares the 4 teleportation modes. Fade is the first one. So in the fade, you basically have, you transition from the current mode to black and there to the new mode. Animate, you basically animate between the current to the destination mode. And in the blend, you mix the current mode and the current view and the destination view. And in the envelope mode, this is our technique. You basically have this magnifying glass, and then you engulf the user and bring it to the destination region. Because we are wearing a head-mounted display, this kind of has an effect that it's actually filling in your entire space, and it has at least some benefits to the user, specifically reducing cyber sickness. So we set up experimental, two major experiments. We use Vive and two controllers, one for the interaction, the other one is part of the user study. And we use this room size of about 9 square meters, which is a relatively small size. We use Unity and a 64, this is the Earth assets from Unity. The data also included data coming from the IRS in the US, Postal Office, Home Development Dataset, a few other datasets that were added as widget on the GIS, and that was part of the experiment. The users had to search and compare and tap during that process. We did ask them after the experiment to fill in SSQ and TLX and PQ. These are standard questionnaires in this kind of studies. And we also asked them to give a preference assessment at the end. We conducted 2 studies, the first one 13 participants, the second one with 25 participants. The first one was just looking at this auto-scaling process, how auto-scaling compared to fixed scaling, and how the context that you get, you look at the widgets in some areas surrounding the users, or the widgets can be placed anywhere in the world. And apparently there was a significant effect on both PQ and TLX, but not on the SSQ. And the user's preference was significant on elapsed time, but was not significant on the total movement or deviation in this tapping test that we did. And you can see in the paper, I don't want to show all the graphs and the results, but that's, I think, was a positive user study. The second user study was about this transitioning, and we compared these 4 transitioning modes: fade, and animate, blend, and envelope. To remind you, envelope was our transition mode. Unfortunately, none of the questionnaires or the presence or performance or even the tapping test were significant. The tapping test was significant, but was rejected later by 2K HSD comparison test. And you can see here in this graph basically that people prefer the animate, and I believe that most people are used to animate, and that's what they use in the teleportation transition. So 50% preferred animate, 40% preferred our technique envelope, and the fade and blend are not as preferred by the users. And you can see in these comments, envelope can cause emphasis and jittering, and envelope blend and fade can be applied to non-translational transitions. So there are some comment. I believe that this is relatively new and may need a little bit more practice by the user. But in any event, these are the results that we want to report. So to summarize our contributions, so we present a mechanism to navigate in large-scale omnidirectional data sets, and these are, as I said, these are in the gigapixel size. We have this method for automatically scaling the data and allow you hierarchical navigation. We combine this zoom and peak before the teleportation, or could be even part of the teleportation in the envelope mode. We look at the Earth as an inside out, and I think that was a very powerful paradigm, and give you a really truly immersive GIS in a head-mounted display environment. And we use this user study, which was not very conclusive on the envelope, but it was a good comparison between these different teleportation transitions, but it was very conclusive about this automatic scaling that we used. And that concludes my talk. Thank you very much.
Any questions or comments from the audience, please? Okay.
Hello, thank you for the presentation. I have a question. The participants for study 1 and 2, are they belong to the same group or different people?
Different groups.
Because I was thinking if they are, they might have bring the preference from the auto scale up to the interaction mode, but...
Right,
but,
right.
yeah.
No, completely different group.
Okay, thank you. That's just...